Hi, everyone, and welcome. Good morning, good afternoon, or good evening, depending on where you are. Thank you all for joining. I know we're about 2 minutes past the top of the hour. I think we might give another minute or so for anybody else to join, and then we'll go ahead and dive in. Okay, I think we're a few minutes past the top of the hour. So once again, thank you everyone very much for joining us. We, if you haven't met us before, are the Digital Initiatives Group with the University of Washington. We focus on a number of different digital health projects, ranging from the more technical to more workforce governance related. We are kicking off a three-part series today on webinars focusing on AI, our work in AI, what it is, what some of the ethical implications are, and what some use cases look like. Today, we'll be hearing from our two team members, Peter Mankowski and Herbert Yiga. So with that, I will pass the mic, so to say, over to Peter. We have a few other team members on the line who will be helping monitor the chat throughout the hour. This will also be recorded and slide shared after the fact. So Peter and Herbert, over to you.
Hello, everyone. It's really nice to be here and basically meet with you guys and share a presentation that originally we were doing as a internal presentation for our group to kind of set a foundation in AI since it's becoming more prominent in healthcare and in global health and in the funding opportunities and in the work that we wanted to be doing. um, we decided to just put together a quick foundational introduction primer for AI in healthcare for a workshop in our internal group. And that grew into this idea of sharing it with a bit of a wider audience and building it out a bit. So this presentation should be hopefully not too long and just give a foundation for what AI is and spark some conversations and some thoughts on the beneficial applications of AI in healthcare, on the risks involved, on the different various types of AI, and specifically on demystifying and separating a bit of the hype that that is around AI nowadays, especially the large language models and tools like ChatGPT and others like that, from the wide range of other both methods and applications of AI in healthcare. So I'll I'll be going through a couple of the introductory slides, and then Herbert will jump in and review some of the major key aspects of AI, key methods that are used nowadays and have applications in healthcare. And then we'll go into a bit of a conversation, hopefully, and also give you a preview of what the next two webinars will focus on. I don't know if Sonora or Herbert, you wanted to add anything else before we get started?
Nothing else from me.
Okay, sounds good. So I think the overall learning objectives, like I mentioned, are to go over the different types of artificial intelligence, what artificial intelligence actually is, and explain some of the key concepts. Connect them to a kind of a broad range of applications in healthcare, and then just review some of the overall strengths and limitations of AI, which is difficult to do because of the wide range of methods out there and the quickly changing landscape. But I think a lot of the points we will go through hold true for the work that's being done out there. So what is AI? As many of you probably know, it's the simulation of human intelligence. So basically, making machines and computer systems able to problem solve and perform tasks that typically we've associated with human intelligence or requiring human intelligence. The nowadays we have a lot of uh, hype surrounding the large language model based AI agents that or generative AI agents that can basically simulate human conversation. But that's just one single area of AI, as you can see in this kind of uh, onion-like diagram with a lot of layers. If we have artificial intelligence up here and then all these different subtypes that we'll go into, our generative language models are all the way down here as like in a pretty long hierarchy. And this shows another view just to give you an overview of the different aspects of artificial intelligence. Again, there are many different areas, many different applications and methods associated with each of these areas. There's overlap, obviously, between them. But if we want to look at where the Chat GPT basically family of methods is, it's all the way down here in this little leaf. And this just shows a bit of a simpler diagram of what we'll be talking about, where artificial intelligence, the all-encompassing kind of idea, is then grouped into three subcategories. And really, all of the AI methods that we're using right now, we haven't quite developed artificial general intelligence, at least not for general use. That's, I think, the next milestone in the AI community that is the goal. But for all of the uses that we have today, they're much more specialized artificial narrow intelligence uses and involve machine learning, which can further be broken down, and we'll go over that a bit. Oops, sorry. So for since machine learning is at the root of almost all of the key AI methods that we use today, this is just an overview of a general process for how to basically train such a tool to do your task and then evaluate it on how it actually performs. So you define a task, you select the model that is likely to be able to perform that task based on a lot of different features, collect some data, train the model, and then evaluate the model. And you can do that iteratively to improve. Um, okay, so now we'll just go over just a broad view of what AI currently is good at and what it's not good at. So some of the strengths of AI are that it is able to much better than humans get a very quick sense of large patterns in large data sets. So it's good for large data set or comprehensive data integration and analysis. Because it doesn't need to be basically governed by sleep or food or other such requirements. It can be very good for tasks that involve 24-hour monitoring or alerts, which is very prominent in healthcare. Um, Due to the fact that, again, it is less human resource intensive than a human, you can usually, if you have the resources to run AI agents, you can scale them much more easily than a human workforce. Um, and AI can, again, make some personalized because of its ability to review large amounts of data and look at patterns. It can be used in personalized applications and in more human interactions like natural language interactions and summarizations. But a lot of the AI methods currently have limitations that we need to be wary of, like uh, the fact that a lot of the models that we use are complicated, and it's difficult to both discern what the thinking behind the results is, or to simulate a true understanding in an AI agent. AI is very dependent currently on the training data and what it's trained on, basically. So any biases, any lack of sufficiently good data will impact the performance. Um, as you can see in the next section, it's vulnerable to bias and hallucinations. Um, and there's a lot of legal issues as well, since um, we're so entrenched in a human-focused society with thousands of years of sometimes legal precedent. It's difficult to figure out who would be responsible for decisions made by autonomous agent and where liability lies and things like that. Um, and obviously, especially for some of the more complicated models that really obfuscate the thinking behind the results, there's a lot of challenges with transparency and accountability. So that's a very, very brief, just quick overview into the landscape of AI and some general guidelines on what it is and isn't good at, which is, as you know, quickly changing. I'll hand it off to Herbert to go into some of the key aspects of AI to dig a little deeper into it. And then we can have a bit of a conversation about how it's applicable in healthcare and what your guys' ideas are. And yeah, so let's go from there. Herbert, if you want to, would you like me to change the slides, or would you like to share your screen?
Yeah, I think you can change them. That should be
Okay,
fine.
sounds good. So just let me know when to go forward.
Yeah, thank you. I think we can move to the next slide, Peter. Thank you. Yeah, welcome everyone to this webinar. I'll just try to quickly go through the key AI concepts. And then, as Peter has really said, AI is simply a simulation of human intelligence, just to make sure that computers or machines really run with these processes. So we really want to, the major goal is really to achieve what really happens for human beings to really be true for the machines. So an example of these processes can really be the ability to do the learning, the ability to do the reasoning, and then the ability to understand languages. So to really achieve all that, AI is really categorized in a number of things. And I think for today we shall mainly concentrate on category number one, which is the narrow artificial intelligence. So when we talk about narrow artificial intelligence, we are simply just concentrating on AI, which really needs an individual to mainly concentrate on a particular task. Yeah, so the other categories of AI actually include things like generic AI or general AI. So with general AI, you are really just trying to concentrate on all what a human being can really do. And then the other category just concentrates on, the other category is super intelligent AI. And then this mainly just concentrates on doing stuff more than a human being. Yeah. So the two categories, that is general AI and then super intelligence, are so much still in theory. But hopefully, as things run on speed, hopefully a lot of works will also be done around those. So I'm going deep to the narrow AI. Narrow AI has an approach which is called machine learning. So in machine learning, what you are simply trying to achieve is you are simply just working with a big data set or a data set, and then you are simply just training that, and then you are making out predictions out of that data set. So the whole concept is to simply work with some set of data, train it, and then use any other kind of data that you want to get the results of, that you want to get the results of, run it off the model, and then you get any kind of predictions or decisions that you want to make. So machine learning really comes with some other approaches. Next slide, Peter. Sorry, Peter. Hello. Thank you. Sorry, Sanora, do you want to pick on the survey right now, or I can first complete a bit?
I
Sure.
think yeah, I think I was just wondering, this might be a good place to just take a quick break with that intro and just get the audience's thoughts on some of the ways they think or have seen or are thinking of AI assisting in the healthcare setting. Uh, and then we can go on to those more specific methods with some examples of healthcare applications and see how they match what we might have not put on them that the audience has, and etc. So it might be a fun exercise.
Yeah, so we've dropped a link to a Mentimeter in the chat. You can also access it from the QR code shared, and there's a code at the top here. But you want to submit a few thoughts on what some ways are that AI could help or be a useful tool in healthcare settings. This will generate a word cloud, and we can't see your responses, but our hope is that this will give us a way to generate some ideas and conversations. Seeing lots of suggestions already coming in. Feel free to also drop any ideas you might have in the chat or just speak up.
Yeah, so we can see a lot of prediction, a lot of diagnosis, some image recognition, um, some decision support, clinical decision support. All of these are definitely key areas of AI application. And just to answer the question from Jesus Castagneto in the chat, I don't know if we can dive deep into it today, but some of on the side of the ethics and privacy, we will have another webinar that's more focused on that. And in terms of like security and uh, using locally run AI models versus cloud-based models and choosing which models to use and um, how hallucinations actually happen and how to validate that. We will have links that might help you, and we will try to touch up on that in the future webinars. And while we're doing this, I'll also share a link in the chat to our to a primer that is kind of a companion to this presentation that you can go to either get a bit of a more deep dive or reference some of the things we're talking about or get links out to additional reading or resources. And please feel free to give us any feedback on these resources that you might have. We're hoping this will be a community resource that will improve and grow over time and help not only our team, but the community itself, like just have a reference point to get kind of a foundational guide to AI in healthcare. Okay, so Nora, I think it's been pretty stable.
Yeah,
And I think we can save these results and maybe reflect on them after the presentation and see if there's any comparisons or things that we missed.
absolutely. I'll go ahead and stop share and pass it back to you and Herbert.
Sorry, Peter. Do you want to get back to that?
Does that work? Okay. Okay, take it
Seems not.
away, Herbert.
Sorry, could you just reshare again? It seems not to be loading on my side.
Oh, sure. You might have two screen shares. Sonora, oh, no, Sonora might have stopped it. Okay, let me try to do it again. Can you see it now?
No. Can I just share from my side?
Yeah, because I can see it. I can see it here. But yeah, you can just share on your side. Maybe it will be easier.
Yeah. Are you able to can you just confirm that you can see it now?
Yeah, we can see it. Great. Thank you.
Thank you. Yeah. So well. I'll just quickly go through the different approaches of machine learning. I'm not forgetting that machine learning mainly works from.
Sorry, Herbert. I think I'll try resharing the screen again because your audio might be cutting out if you're also using video. While Herbert is, I'm not sure, Sonora, you can't hear Herbert either, right?
No, I can't. I'll
Okay.
send a message.
So while we're figuring out those issues, I think there might be some connectivity issues on his end. I'll just go over some of the things. So basically, the first area that we'll dive into is supervised learning, um, where AI models are trained on data that's already been labeled. So it's like expert labeled data or data that's naturally labeled. Um, so for example, if you have a list of patients and you assign disease states to them based on clinical diagnoses made by a doctor, that's an example of labeled data. And then the model can use those examples to train whatever um, internal variables it has, whatever internal model exists to perform well on this training set of data, and then apply that model to new data, and then validate how it does on that new test data. So this is very widely used and has been for many years. And some of these statistical methods predate computers. Um, but some of the example applications are prediction and diagnoses, like uh, prediction on whether some tumor is going uh, to be malignant, for example, or detecting pneumonia from patient X-rays. Um, the issue or not an issue, but one of the drawbacks of this approach is that it does require a relatively large and good quality set of labeled data, which is, especially in the healthcare setting, not always easy to to collect and validate. Herbert, if you're back and want to take over, just let me know. But I'll just continue for now. So for unsupervised learning, in this case, the set of methods that is used in unsupervised learning does not require any human or other labeling of data in order to run those methods. And it looks at the data, the raw data itself, and tries to identify different patterns or categories in it. So one example could be looking at a set of patients and trying to figure out the different subgroups, disease subgroups that they might have just based on their, let's say, genetic profiles. There's no guidance going into it about the subject. It just the model's ability to detect these patterns and interpret these patterns um, that that really is key here. So unsupervised learning can be used to uncover insights in unlabeled data, in data that's raw or has no additional metadata associated with it. And one example of this is like clustering methods, like I just mentioned, or anomaly detection, since it is good at revealing natural groupings and outliers. And then we have hybrids of these two approaches, like the semi-supervised learning, where you might have a small amount of labeled data, which again can be expensive to get, and it might require extensive manual labor or human expert time. And then you also might have a much larger data set of unlabeled data, and you can leverage the information, the knowledge from the labeled data to improve the training of the model and create a sort of pseudo-labeled data set that is better at generating models than just using either untrained or the small amount of trained data. So as you can tell, this can be very useful in healthcare where raw data, especially nowadays, is plentiful, but annotated data is much more, especially accurately annotated data is much more difficult to get your hands on. Herbert, I'm not sure if he's back, but anyway, I'll keep going. So another class of machine learning AI approaches is reinforcement learning, which you can think of as kind of a gamified approach to training these models, where where you really are working with an environment and an agent that is interacting with the environment. And as part of the environment, the agent just naturally learns what the beneficial routes to solving a problem are, because all you input is, hey, this is what winning looks like, or this is what losing looks like, or this is what winning and losing look like. And by running in that environment with that feedback, the agent, with those rewards and penalties, the agent over time is able to train itself to maximize the cumulative reward. Um, so this this approach allows different models to, for example, refine their functionality over time and get better, or again, with no preconceptions about approaches, develop a strategy that can be optimal in a given environment, and apply it to in that case. And another kind of side concept that I wanted to touch upon is transfer learning, where you take a model that might have been done for one task domain or data set, maybe a more general domain, right? And then already take what was trained, and apply it and fine tune it in a second domain. Um, so this is especially in healthcare, again, where data scarcity is a big issue. This can be a beneficial approach, since you can leverage information more, even if it's more general, from other domains, um, because there might be a lot of crossover still. So, for example, in image recognition, you could have a model that's already pre-trained on general images, and then just fine-tune it on domain-specific clinical images. Or for LLMs, you might have use a general large language model and then further refine it to be better at both comprehending and being able to output clinical texts or understanding medical jargon, for example. Then one of the last ones we'll go into is deep learning, which is at the core of a lot of the more advanced AI methods nowadays, including the large language models. So deep learning is a subset of uh, and machine learning that uses artificial neural networks, which is kind of conceptually like a way of creating models that mirrors how the human brain works, which is why it's called a neural network. And basically, this allows, if you look at this diagram here, which is a bit small, I'm really sorry about that, but this approach takes some inputs, puts them through a model with different layers of nodes and connections between the nodes that can all have different functions and weights associated with them. And then there's a set of outputs. And when you train the model, you basically the model assigns or learns what weights on this very complex internal network of nodes um, al allow or optimize the output. And based on that, it's able to detect very complex patterns that are difficult for humans to see. But at the negative side, it frequently the actual logic or whatever is motivating the results is very hard to discern or explain in a human understandable way. So deep learning can drive major advances because it effectively analyzes complex data, but it does present explainability issues. So some additional concepts that I'll quickly touch upon. So large language
Sorry,
models.
Peter, I think
Oh,
we do have
yeah.
Herbert back on if we want to try
Oh,
to
okay.
test and see if his audio is working better now.
Sure. Herbert, do you want to quickly jump in
Absolutely.
and finish this slide or?
I think you can go on, Peter.
Okay. Okay.
Okay.
Sounds good. I'll just finish up then. So the like I mentioned a couple times, the large language models are a subset of these neural network architectures that are trained on really large data sets to simulate basically human understanding and conversation. Um, and they have many possible applications in AI, and kind of a related um, field is natural language processing, which enables text or speech capabilities, and again is very applicable in healthcare, where a lot of information is encoded in free text or in speech or in other ways that are frequently hard to get the data in a standard way into some analysis or some use. And even more concepts that you can go into, including computer vision, explainable AI, which is key in healthcare since if AI is making decisions, we want to know what the logic behind them is. Um, we discussed some privacy issues, so the federated learning approaches are key in order to secure patient or sensitive data. Um, Local AI is another application that would be very useful in healthcare, and obviously all of this can feed into much more extensive clinical decision support systems that can in a much more natural way integrate in current or existing workflows and help instead of hinder in the clinical space. Okay, so that's a very uh, quick overview of the main areas of machine learning and AI. I'm sure we've missed some things or could have went into it deeper. Just to review some more high level concepts. So where AI helps versus where it falls short. So AI is a good fit in pattern recognition or high volume repetitive tasks, speeding up basically those tedious tasks that require repetitive actions. But currently, it might be a worse fit in context heavy decisions where, especially where human interaction or empathy might be required, or where there's sparse data to actually train the models, or the data quality might not be good, or where explainability, transparent rationale, accountability, legal issues are a big key. Um, we will go into this much more deeply in a future webinar, but especially when using AI in healthcare, it is key that we think about responsible and equitable use in terms of both bias and fairness, accountability and transparency, data privacy and security, and access for different, possibly disadvantaged populations. Um, and then, yeah, these are just some examples. We went into this a lot. I want to also just highlight the third webinar that we will have. We will be focusing on a AI project that our team is working on related to the Open Ella's global lab information system that we manage. that we are the stewards of. So I encourage you to check out these links if you want to follow along with the work and join at a later date to take a look at where we got with it. So basically, this application will try to help with users being able to do reporting and analysis on data collected in a lab information system. So yeah, these are some key takeaways that I went through, so I won't read this whole paragraph to you, but what I do want to highlight is these links. So the primer that I shared in the um, chat, it's a bit text heavy and needs more images, so I'll try to work on that. But it does have a pretty readable, I think, and with the help of AI generated overview of the things that we discussed today, um, that you can kind of read at your own pace. There's also a link to these slides, which is less useful since it's in the slides themselves. But I'm hoping uh, Jen and Sonora, we can share it out just to people that would like it, and I will also add it to the primer page so that you have a one-stop place for it. And then there's a little AI tutorial um, that we have if you want to just try out some AI approaches with Python, if you're that tech interested. Yeah, I think that's all I have. Herbert, if you want to add anything, I'm sorry you had some connectivity issues, or Sonora or others, feel free and I'll take a look at the chat.
Thanks, Peter. Thanks, Herbert. Cliff, I see your hand up. Go ahead.
Yes, thanks, Peter. Thanks, everyone. Great presentations. I saw there was a question about the hallucinations, and I just wanted to comment on that, maybe just to supplement something. So mainly with hallucinations, the two primary solutions are mainly is what we call RAG, retrieval augmented generation, and then fine tuning of the LLMs. So with RAG, they add another layer whereby before we send a user prompt to the LLM, I would say beef up the user response with more information, contextual information that we may be tapping from another database. Usually they're called vector databases that may be having information that is, I would say, niche based or tailored to a particular domain. In this case, would be the health domain, and add up more context before it's sent to the LLM. So usually RAG is one of the approaches that I use to solve this issue, and then also, of course, fine tuning the LLM and the medical data that you're going to be using. Yeah, thank you. And probably maybe for things like privacy and breaches, of course, strict security measures can be enforced. Things like role-based access being emphasized and enforced. And then, of course, there is data minimization and anonymization, and then also preventing SQL injection. So something of that sort are also attempting to reduce that kind of approach. And also, of course, there are what we call LLM firewalls that can also be implemented to curb some of these issues and to try and mitigate them. Thank you. Don't know whether that answers Jesus's question, but yeah.
Yeah, thanks so much. Anyone feel free to jump in if you have any thoughts on it or other questions. Okay, hearing none right now. In the chat or in the call, if anyone has any other suggested discussion topics, feedback, questions, ideas, I think we can use the last few minutes of the webinar to share them, discuss them, or if everyone just wants um, to take in what they learned today and send us feedback later, that's also possible.
So I've shared something in the chat about the rug for folks who will be interested to read about it. And yeah.
Perfect. Maybe I can add that also to our resources.
Sure. Thank you.
Yeah, I think we still have time for questions, but as folks are thinking of things, I wanted to share on the screen a link to the registration for or the QR codes for the next two sessions that we'll be having. We'll have a session on ethics and AI that Peter was referencing next week at the same time. And then the week after, we'll have that session on AI and a use case on how to power lab management. So we can also make sure that this is linked in the chat and elsewhere, but wanted to keep the QR codes up now for folks.
And I just wanted to check the link that I shared for the slides. Does it work for people or because I got
Yeah, it should be viewable to all, but if folks are having a hard time accessing it, please let us know.
It's working.
Okay, great.
okay, perfect. So yeah, I think a lot of the questions about the more ethical or what's the right way to do it in terms of legislation, regulation, we will dive into that a bit in the Ethics in AI webinar that's on April 2nd. So I'll make sure to to grab all these ideas and questions and make sure we touch up on it then. Okay, well, I just wanted to say thank you again for this really great turnout and all the excitement about these series. It's good to, put things together, share it with the community, and have these conversations going, especially with how relevant AI is becoming in both our field and in general. So thank you.
Thanks, Peter.
Oh, as a final note, I think we will share this recording on a link to this recording on YouTube, so you can also look out for that and share with anyone that might have been interested in joining but couldn't make it. Okay, bye everyone.
Bye. Thanks.